Part 2 of the Growth and Development Lab is looking at weight changes and body composition changes during lactation. Now, at the very early part of lactation, the energy expenditure in the milk and the nutrients that are being pushed out in the milk are more than the animal's getting in its diet. So there's more going out than coming in. So to meet the deficit, to make up the difference, the animal has to mobilize its own body tissues. So in this lab, we're looking at real data from an experiment some years ago where the researchers took ewes that were of a very similar body weight at lambing, and then they looked at the difference in the carcass after 5 days of lactation and 40 days of lactation. So they use it just looking at the carcass, so all the internal organs have gone, so that's got rid of the gut and gut fill, the fleece and skin has gone, feet and head have all gone. So just looking at the carcass, and visually this is the sort of thing they would have seen. So this would have been after 45 days and after 5 days of lactation. And you can see the difference in fat cover just by eye. You can see how the fat builds up, especially on the rump here, which is where farmers and stock agents, they use this area to judge the fat cover on an animal. So in this lab and in the spreadsheet, we'll get real numbers associated with the weight loss of the animal in lactation.
Okay, so let's have a look at exercise 2, and this is putting some real data to the changes in body weight and composition during lactation. So what the researchers did was to take animals that were a similar body weight when they started lactation, and then they looked at the composition of those animals at day 5 and day 45. So there's a bunch of data here. We've got the fleece-free body weight, fleece-free just to get rid of the fleece so that it's not an independent variable, the gut fill, the carcass weight, and then the makeup here, and we're going to do some calculations down here. So I've already transferred the fleece-free body weight down. So at day 5, these animals are about 74 kilograms, and day 45 they lost a bit of weight and were down at 67. That's a change of minus 6.6 kilograms, which is about 9%, which doesn't look that much. So let's fill in the rest of the calculations that are required. So KO percent, killing out percent, this is the KO stands for killing out, and the killing out percent is the percentage of the animal that ends up in the carcass. So to calculate that, we just take the carcass weight and divide it by the fleece-free body weight and express it as a percentage. So at day 5 of lactation, the carcass was 45% of the total animal, and at day 45 of lactation, it was only 32%. Empty body weight is EBW, that's what empty body weight stands for, empty body weight, and we calculate that just by taking the fleece-free body weight and removing the gut fill. So that 74 kilogram animal was at empty body weight comes down to 60, and the 67 one at 43.8. Fat-free empty body weight is just that body weight there minus the fat content. and the empty body weight component. So this is just the makeup of the empty body weight, and do that. Oh, no, don't do that either. So I just want to transfer this data down up here down to here. So just copy it down. Okay, and we'll look at the changes in these different parts that we've calculated. So initially, fleece-free body weight, 9% change in that 40 days of lactation. But when you look at the killing out percent, so the carcass, there's a 28%, and empty body weight also 27%. And the reason that this is much greater than the change in the fleece-free body weight is this animal here, day 45, the gut fill was 10 kilograms heavier in this animal than this one. So the change in body weight had been masked by the fact that this animal was carrying around a lot more gut content. So as I said in the introduction, you have to be careful when you're weighing an animal as to what you're actually weighing. And this is an example of how other factors can mask the change in the actual animal. So when you take that into account, you've got a much bigger change. So empty body weight, all of a sudden the animal has lost 27% of its body weight. And here, the fat-free empty body weight, the change is only 7%. So if you take the fat out of the equation, then the change is much less. And when we look at the components of the empty body weight, so the animal, the empty body weight of the animal, and look at what that's made up of, and got fat, protein, water, and ash, the big change is in the fat content. Nearly 70% of the fat of the animal has been lost in those 40 days of lactation. So going from here to here. So it's lost almost 10% protein and some water, no ash that we can see in this data. So when the animal loses weight, and it's losing weight because during lactation the animal can't physically eat enough food to meet the energy demands on it. So that milk production means that it just can't physically take in enough energy and nutrients to meet the outgoing demand. So it's what we call energy deficit. And to make up the deficit, it has to mobilize its own body tissues, and the bit that it mobilizes most is the fat. And that's what it's there for. It's there as an energy store to be used when the animal's in energy deficit. There's more going out than coming in. It doesn't only use fat. It does mobilize a bit of protein, but by far the majority is fat. Just look at this last row here, body energy. So how much energy is in this body as opposed to this one? And up here we have the energy content of fat and the energy content of protein. Each kilogram of fat has got 39.2 megajoules of energy, and each kilogram of protein has 23.4 megajoules. So that means down here we can work out the energy in the animal at this point versus this point. So the energy equals 19.5 kilograms of fat times 39.2 megajoules per kilogram plus 8.19 kilograms of protein times 23 megajoules. So 958 megajoules of energy in the animal at this point. If we copy that across here, it drops to 412. So a big drop. If we look at the change, so it's lost 545 megajoules of energy, which is over half, 57% pretty much. So the reason it's lost so much of the energy is because the bit of the animal that's been lost is the high energy part. Fat carrying almost twice as much energy per kilogram as protein. So if you've lost the high energy part of the animal, then you're going to make a big difference to the body energy. So take-home message is, if the animal is in energy deficit, first body tissue to disappear is fat.